All right, let's look at the practice exam 3, problem number 5, part B. All right, let's evaluate this limit. All right, first thing you should do is just to kind of plug in the x value and see what happens. All right, x is going to infinity, so we can see that here. So 1 over x is going to go to 0, so you have a 1 plus 0. So this guy is heading toward 1. Right, but the power is obviously going to infinity. Right, so you have basically 1 to the infinity. Right, this is one of the indeterminate form, so we can apply L'Hopital's rule here. Right, so before we do that, we have to do a little bit of tweaking so that we can apply L'Hopital's rule. All right, so let's do that. All right, so first we're gonna have, all right, so I'm gonna leave the limit for now. So limit as x approaches infinity. All right, then what we're going to do is we're going to do this trick. We're going to put that e to the natural log of, all right, exponential function and a natural log functions are inverses of each other. When you compose them together, they basically cancel each other out. So it really doesn't do anything to quantity 1 plus 1 over x, raise it to the x. All right, and the reason why we want to do that is that because we can use one of the log property where we can move this x. So I'm going to just scratch that out and put it right in front. All right, so that's using the log property. All right. But in order to apply L'Hopital's rule, we would like to have a fractional form. So what we're going to do is this. So I'm going to leave this limit for now. And x is approaching infinity. All right, e to the. All right. So instead of writing as multiply by x, I'm going to write it as divide by 1 over x. Because this is essentially double reciprocal. So it's going to be just same as x. All right, then you have a natural log of 1 plus 1 over x. All right, then next thing we want to do is since that exponential function is continuous, we can actually squeeze this limit inside the exponential function. All right, so we get e, then you have a limit as x approaches infinity. Then we have natural log of quantity 1 plus 1 over x over 1 over x. All right, then we just kind of plug in and see what happens. All right, so if you plug in x equals infinity, the denominator approaches 0. All right, numerator approaches natural log of 1 plus 0. So natural log of 1 and a natural log of 1 is actually 0. So this guy approaches 0 as well. All right, now we have 0 over 0. So that's the indeterminate form for L'Hopital's rule. So we can apply L'Hopital's rule now. So applying L'Hopital's rule here. All right, so you have e, right? Then we still have a limit, but what we can do is we can take the derivative of the top and bottom, right? So derivative of the top is going to be, all right, natural log of anything. Remember that if you have, say, natural log of, say, g of x. If you want to take the derivative of this guy, all you have to do is whatever inside the natural log, write it as the denominator and take the derivative of that and put it on top. All right, so here, same deal. So we have 1 plus 1 over x, put it on the bottom, denominator. And to take the derivative of that, put it on top. Derivative of 1 is 0, so I'm not going to write anything down. Derivative of 1 over x is negative 1 over x squared, right? Just a power rule. All right, then we can take the derivative of the denominator separately. Derivative of 1 over x is again negative 1 over x squared, right? So good thing is we can actually cancel this negative 1 over x squared, and there's the same thing here, so that's going to be 1 there. All right, then what we have is, right, so we have e to the, all right, so as x approaches infinity, 1 over x approaches 0, so you would have 1 over 1 plus 0, right, which is a long way of saying 1. So you have e to the 1, which is just a e. All right, so this is the limit. All right, that's it. I hope that this was clear.